Welcome to series of classes on organic chemistry. Today's class is class number 11, and today I have targeted to solve all the in-text question and a lot of competitive exams questions on alcohols and phenols. So you first minutely follow the class, and I will give the clue to solution of each and every in-text question, and these are of very important for exam point of view as well as entrance point of view. Acidity. So in a textbook it is given C6H5OH and phenol, and it is asked to explain why phenol is more acidic than ethanol. So ethanol is acid and it loses one hydrogen as proton. Alkoxide part is this, ethoxide pass, and phenol when loses one oxygen it becomes phenoxide ion. So phenol or anything will be acid if on losing hydrogen as proton the negative part itself become stabilized. If this part is stabilized instantly, then this will be, the acid will be more acidic, and if this part is stabilized instantly, again this one will be, the alcohol phenol will be acidic. But out of these two, if we compare the stability, we will find the resonance stabilization is much more in phenoxide than in ethoxide. So due to resonance, stability of phenoxide ion is more than C2H5O negative. That's why phenol is more acidic than ethanol. Next, RCH2OH, RCHOH, RRCOH. If I ask you to arrange the in order of increasing or decreasing order of acidity, so what will be the order? The order will be of this, because here plus I effect will play important role in acidity, because more easily the O will get detached from it as proton, more stronger will be the acid is. So plus I effect means it releases electron or pumps electron. So when this group pumps electron, the density between electron density between O and S will move, hence H will not or will not tend to detach from it from S proton. So more the number of R group, I group, more will be the density of electron, less will be the tendency of the protonation. So weak will be the acid is. But the concept will be very simple one. These are not tough. I will not pass time. Shortly I will say this ortho or para. Which one is the acidic? Here this is minus I group. So when it withdraws electron from the ring, the bond between O and H will be weaker, and this will facilitate hydrogen to go out as proton. So that one will be more acidic than this. Now if I take the example of say if I ask you to tell which one will be the more acidic. Now that one is electron withdrawing group and this is electron pumping group. So when the electron hydrogen is being released from this one, it pumps electron and more electron density will be accumulate upon O negative. That's why the ion stability with resonance will be hampered, so it will be less acidic. But on the other hand, N auto group withdraws electron, so OH bond will be deficient in electron weaker, and that will facilitate the removal of hydrogen as proton. Therefore that one will be more acidic than this one. Again another question comes in entrance, also in normal board exam. Phenol 2 4 6 dinitrophenol. Naturally that one will be more acidic than this. So if I now very important one question I am trying to explain. Phenol or paranitrophenol or orthonitrophenol. If I ask you why paranitrophenol or orthonitrophenol is more acidic than phenol? Very simple way you can understand that. A bit earlier I have told you that nitrogen is electron withdrawing groups, and due to the effect of electron withdrawing effect of NO2 group, at that bond becomes weaker, and release of H positive and S proton will be facilitated in presence of NO2 group. Therefore phenol, nitrophenol, para ortho or para nitrophenol is more acidic than phenol, and you are satisfied with my reply. But the fact is that a bit earlier I have told you, whenever that hydrogen from this or that is get removed, what happens? In both the cases we get phenoxide ion. Either here there is no other substituent, but here there is one substituent, nitrogen. When it loses electron, we get this. So now question is, a bit earlier I have told that a species will be more acidic if on release of hydrogen its negative part gets stabilized. If the stability of that negative part is more, then the compound itself is more acidic. If it is happy releasing after H as proton, then obviously it will release hydrogen as proton very easily. And if it is not happy after release of H as proton, then it will no longer want to release, or it will not easily want to release hydrogen as proton. So in both the cases, this and that one will release proton, and both the cases there is stability. Here you will get stability by resonance, and earlier I have shown you it has got some resonating structure. This will withdraw, again this will come, this will withdraw, this will come. That's why the negative part tin oxide ion will be stabilized. Now what's happened here? Say ortho and para in both the cases is same. In both the cases, ortho and para in both the cases, the matter is same. Say it has released one hydrogen in ortho position. I have 1 2 3 4. I have written it here in this way. Let's see what's happened, why it is more acidic. So we get, you minutely follow how I draw this structure. And double bond or bond, here There is a bit a peculiar explanation is there. You minutely follow me. I hope you can understand the explanation very easily. And it will go on, it will go here in this way. Very simple way I am showing you. One of the fact is that uh, this is the fact lies here. Here we are getting the resonating structure. This is stable. Again we are getting here resonating structure, but the contributing structure in case of para or orthonitrophenol is more contributing structure. More contributing structure. More the contributing structure, more is the stability, and more easily it will try to release hydrogen as proton, and more will be acidity. So why? Because that carbon has got negative charge on it, and due to presence of this negative charge, besides going to change delocalization of electron, resonance in the electron in the benzene ring, it has further extended outside of this one, that causes more and more contributing structure. So due to the presence of negative charge on carbon along which withdrawing group NO2 is attached, because its main aim is to pull out electron from this one and destabilize the benzene ring, but due to the that electron withdrawing group is attached to carbon, and on this carbon negative charge is delocalized, and due to delocalization of due to accumulation of negative charge on carbon, that charge involved resonance outside of the ring, and that gives more and more contributing structure. And why I am explaining this point, because sometimes very often one of the very confusing and very controversial point, lots of scholars, chemistry scholars are of different opinion. Why, if this is in meta position, we very often write the action of meta position, nitro in meta position is less acidic. Metanitrophenol is less acidic than paranitrophenol. That is, paranitrophenol, orthonitrophenol is more acidic than meta. So if this is in meta position, what's happened? So at home you will draw, you try to draw, you see whenever this nitro group is here in meta position, you will never get that negative sign accumulated on that carbon. Because of this fact, the resonance only restricted to the benzene ring itself, doesn't go out when it is in meta position. That's why it restricts the contributing structure. So when nitro group in meta position, it doesn't give so many resonating structure. Therefore orthonitrophenol is less acidic than paranitrophenol. Sometimes there is some controversy, a lot of questions are there. Till for time being we can accept this. So this is some way I have explained some of the interesting facts which are explained in your books, and very often these questions are being asked also in your exam. Am I right? Now I have entered into textual question. So CH2 CH2 number first question is OH, and a bit earlier I have told you zinc chloride and concentrated HCl. This is Lucas, and I told you alcohol becomes alkyl halide when we have tested it 1 degree, 2 degree, 3 degree. Since it is 1 degree, answer actually we do not write the question answer, we just write the reason that when it is alkyl halide, it doesn't readily mix with the water. Turbidity does not appear at room temperature, but upon heating the turbidity may appear. If it is 2 degree, alkyl halide again will produce, and this alkyl halide will produce turbidity within 5 minutes. if the alcohol is 3 degree, turbidity appears immediately, because 3 degree 3 degree the CH3 will get alkyl halide of 3 degree types, and that alkyl halide is strongly not easily soluble in water, and we get turbidity. Am I right? So this is first question. Second question I will not discuss. Again, there is OH and Lucas reagent. In place of OH, you just place I think Cl. This will be your answer. Next question is mm, question is this acid. Very often you can see that it is very simple question. Sorry, it is very simple question. You can answer it, but minutely follow. Maximum of you cannot answer this one, because I have shown you when there is alcohol, there is lone pairs of electrons. Am I right? When there is acid, sulfuric acid, then there is first protonation. That will just hold this one. So what we get here is a bit whenever you just follow the mechanism, then you will find it easy to answer, otherwise it will be difficult for you to answer. So next step, the water leaves out or go out. So what we get is go out, what we get is CH2, CH2. And here there is plus charge, because that carbon has got positive charge. So what's happened here, there is hydrogen, am I right? And that hydrogen deprotonated, and we get the answer as this. Am I right? There is other possibility of getting the answer. Other possibility is that uh, from this, when cation is formed, that may be protonated, and that is come forwards in this way, and we get this one. Sorry, we get this one, but that is minor, and this is major. Am I right? So this is very simple one, but explanation is a bit hard, so you try to follow the small mechanism, you can proceed the answer. Next one, which one very interesting, which I am showing you, and you minutely follow this, because basing upon this we will solve a lot of other problem. CH2, CH2, and in your book it is given, you are asked to acid hydrolyze it, you are asked to give mechanism. Am I right? No matter, you can give mechanism very simple way. Bond is withdrawn, and that comes here, CH3, CH2 double bond, CH. Where bond is withdrawn, in negative charge is there, that minus positive part will get attached with this one. So here 2 and 1 hydrogen, you are getting 3, and this plus is, this part is positive, because that bond has been withdrawn here. Am I right? So next part is very simple. Water has broken into OH negative and H positive. Am I right? First, uh, bond withdraw, the negative sign comes here, and that negative H plus attached with negative part, that become positive, and OH negative is there. It will come forward here. So CH2 bond, CH3 or H. So this is very simple mechanism, or also you can write you can, if you don't break it in this way, and you can write it in this way also. um, CH2 bond CH3 plus, am I right? So water as water you can write in this way also, attack here, and that is CH2 OH H CH3, this is plus, goes out, gives out CH2OH CH3. This mechanism very simple. First you add up hydrogen here, CH3, you will get plus part cation, sorry, carbocation, and water is a lone pair is there, it will attached, nucleophile will get attached with this one, we will find O 3 bond plus deprotonated, and plus charge is satisfied, we get alcohol. So what the main intention is that if I don't follow the mechanism, so blindly I can write the answer as CH3 CH2OH in any part H, any part OH. Am I right? But if it is not symmetric, unsymmetric, say CH3 CH double bond CH2, I am emphasizing upon this one because a bit later you will understand why I am doing so. In this position, in this condition, but in which carbon will add hydrogen and in which carbon will add O is negative, that will follow exactly the Markovnikov rule. The negative, that carbon has less number of hydrogen, it has got more number of hydrogen. So according to Markovnikov, negative part will get attached to that carbon on double bond which has less number of hydrogen, and positive part will go to other side. This is the answer. So the fact is that when alkene is there, hydrolysis of alkene, we get alcohol. So always very important path or mechanism or the way to get alcohol, we need alkene. That's why next part in the uh, question, actual question, you have been given to solve out 1 phenyl ethanol from alkene, 1 phenyl ethanol from alkene. You are asked to prepare. Very simple. What is 1 phenyl ethanol? These are a final product. Am I right? C6H5 C C CH2 1 2 3 4. This is 1 phenyl 1 phenyl ethanol. This is 1 phenyl ethanol. So main point, we have to choose alkene. We have to choose suitable alkene out of which we will get methane. A bit earlier, just now I have told you, when double bonded compound is there and if you make it acid hydrolysis, so in one part there is H and other part there is OH. Am I right? So since it is alcohol, it means somewhere there is a double bonded alkene is there. This is benzene part, this is benzene, and that part is CH double bond CH2, it is alkene. Now if we acid hydrolyze, means O is positive and O is negative. Just now I told you double bond is there, HONH, you follow Markovnikov rule. So I am to just make a correct choice of alkene, and that alkene, no doubt it should be remain intact benzene, and other part will be alkene. That alkene, no way out, we should write CH double bond CH2. So now what we will do, according to Markovnikov rule, negative part will get attached with this one. So we will get the answer as CHOH CH3. Very simple. So the earlier concept where we have shown the mechanism of ethene, when it is hydrolyzed we got alcohol ethanol, and that mechanism will follow each and every cases, we will get the answer ourselves without or without repeating, without practicing each and every one again and again. From our concept we will write the answer. Next question is, it is very simple. uh, we need not think about anything. H2Cl, you are asked to convert it this one. In my very beginning of the alcohol and ether, I have told you, when potassium hydroxide alcohol is given, it elimination reaction is occurs, and when potassium hydroxide aqueous is given above arrow, it is substitution reaction. So here chlorine is there, and in place answer is CH2OH. So simply we'll use potassium hydroxide aqueous. Nothing to think. Am I right? So next question is oxidation of phenol. I will not explain it. I have done it. Next one is propane to all. Propane to propane to all. Very often you get confused what to do. I am showing you. Keep faith in me. I will show you the trick how to find the question's answer. Because when there is a conversion, we need some advanced thinking. And what is that advanced thinking? I am showing you. Propane CH3 CH2 to CH3 CH3. We have just written the structure. What we have to convert is propane to propanol. In blank mind, if you think how will you convert, you will never think, you will never find the answer, the result, the way, the mechanism. Am I right? So what we want to do, it is alkane, very less reactive, you know it, it is paraffin. Am I right? So by this or that way, we will first try to make it a reactive, a bit reactive by converting it. So alkane generally does not react. So what we will do here, when alkane is there, whenever you will get in chemistry alkane, that alkane is made alkyl halide. That alkane is made alkyl halide. So you use bromine. So what will happen? CH3 CH3, you will get bromine. So you may ask that, yes, alkyl halide, we have got an alkyl halide. So from alkyl halide, our mission or target is alcohol. So how can you do this? A bit earlier I have told you that to get alcohol, our way, our path is by any means we need alkene. Am I right? So also just now I have told you, when you use potassium oxide in alcoholic medium, elimination reaction occurs, means double bond or triple bond is the result of the reaction. So we will concept this mechanism, this concept, that when alcohol is there, we will just use potassium hydroxide alcoholic to make it elimination. Sejaf rule, more substituted product will be, I will not make it lengthy. So we will just potassium hydroxide alcohol. So what will happen here is um, uh, CH3 CH double bond CH2, one hydrogen from here or one hydrogen from here and one bromine here, both the cases same. So H and B will be come out and will compensate the reaction. The structure as double bonded, we are getting alkene. So just now we have shown that when alkene is there, we will make acid hydrolysis. So on acid hydrolysis, we will follow Fitchep or sorry Markovnikov rule. Negative part will get attached to that carbon having less number of hydrogen on both sides of double bond. So we will get CH3, CH, OH and CH3. So our mission is fulfilled. So beforehand you can't think this. If there is alkene, make it alkyl halide. If there is alkyl halide, make it alkene by potassium hydroxide and alcohol. When there is alkene, you make hydrolysis with acid. That's why acid hydrolysis in your chapter, there is tremendous pressure upon acid hydrolysis of alkene, because a lots of things will happen. And at the end of this chapter, I have prepared 10 or 15 type of uh, acid hydrolysis of alcohol, which involves rearrangement from different type of entrance exam, so that you if any question asks in your exam, before getting the result, when you get carbocation, you try to make it rearrangement by shift of hydrogen or methyl shift or phenyl shift or ring expansion, then you write the answer. Because this year a question came in your exam, that was CH3 CH CH3 CH OH CH3 and HBr. Many of you couldn't answer this one due to lack of knowledge of rearrangement or shift of methyl or uh, hydride or phenyl or ring expansion. When you get carbocation, instantly you made the reaction attack of nucleophile upon that positive part, and your answer become wrong. So when there is HBr, it is this. So this is lone pair. The first step is the protonation. So CH3, CH3, CH, CH, OH2 plus CH3. Next step is loss of water. So you get is CH3, CH3, H, CH plus. You make the blunder here. Many of the students make the blunder here, because when you get that carbocation, your nucleophile is there, you madly attack that nucleophile, you attach the bromine here, answer is wrong. So very often I told you that when you get the carbocation, you just check whether there is rearrangement. It is no doubt 2-degree carbocation. If you see, if you can convert it by 3-degree carbocation, so stability will acquire, then you will attack with bromine. Am I right? So you write CH3, you make shift of hydride shift. Am I right? So CH3, C, CH3, CH2, CH2, you are getting 3-degree carbocation here. Now you attack with bromine. Am I right? Your answer will be 100% correct, and you would have secured 4 marks rather than 1 negative marks. This is the answer. That's why I have structured a lot of question on rearrangement on this chapter. At the end of this chapter, I will show you, or you minutely follow me the textual questions answer, and I am very easily coming to the point. Then the textual questions reagent used. So reagent used, one of the question, um, if I if I if I tell you before going to your question, textual question, if I tell you uh, to make it react with PCCl, So you know it is very selective, it will not have any effect upon this one, it will just convert the CH2 into CHO. So the answer will be this one. Mind that you don't make CHO further, you don't make it CH2, don't make it further reduction COOH, because it is mild oxidizing agent. Pyridinium chlorochromate. Now, what is the question of your text? Oxidation of 1 degree alcohol to carboxylic acid. Very simple. K2Cr2O7, K2, K2Cr2O7 in presence of acid. I need to explain because it is strong oxidizing agent. When your alcohol is say CH3CH2OH, am I right? If you use K2Cr2O7 H positive, then it become CH3CHO, and this on fire. This is strong oxidizing agent, am I right? On oxidation, that will become COOH. So in the textual question, it is asked when 1 degree alcohol, I want to convert it into carboxylic acid. So what is the reagent is to be used? Answer: reagent is required to be used here is K2Cr 1 degree alcohol to aldehyde. Just now at the very beginning, just now I told you, if it is 1 degree alcohol, if it is strong, that CH2 will convert into CHO, and further this will convert into COOH. But since it is weak, we will here use PCC, and the reaction will stop here, it will not go further. So here it is asked 1 degree alcohol is to be converted into CHO, what reagent is to be used? Answer is PCC. This was a very common reaction which was many a times discussed earlier. This is, if I tell you the question is simple. Phenol, bromine aqueous, that was 2,4,6 dinitro tribromo-phenol. So what reagents are being used or is used to convert phenol into bromine substituted compound? This is the answer. Number 4, benzyl alcohol to benzoic acid. Benzyl alcohol to benzoic acid. Very simple question, very simple answer. Benzyl alcohol to benzoic acid. So your target point is this to this. When you will find this one thing you keep in your mind, that it is nothing but oxidation. So you use alkyl this dehydration of propane to propene. What reagent? It is dehydrating reagent is sulfuric acid. You just use the temperature mention the temperature. Propanol CH3 propanol to propene, and it is a very common reagent, H2SO4, and you just mention the temperature. Propanol to propene, water is removed. Dehydration reagent is sulfuric acid, and here that things occur for your clear understanding. You can write in this way. So water is removed, and bond is, when these two bond loses OH and H, bond is rearranged, is become bond become single bond to double bond. So reagent is this: butane to own to butanol 2. So let us first see what is butane to own. CH3 butane to on to butane to all. Now if you minutely see observe one thing, so how can you guess what reagent is being used? First of all, you know what group is converted to what, is not it? So it is reduction type of reaction. It is reduction type of reaction. And how reduction is used? We can use lithium aluminum hydride or sodium borohydride. So reduction means, again and again I mention this term reduction, that is CH3C double bond O, one O is H is here and other H is here. Am I right? So you see, addition of hydrogen is called reduction. So if you use sodium borohydride or lithium, both are reducing reagent. So what happens? Two hydrogen is being added, one hydrogen is to H, other hydrogen is added to carbon. So CH3 CHOH CH2 CH3. So you are getting butane to own to butane to all. So this is type of the reagent used. It is the solution from your text. Now next part is again very interesting, and you should know how to do this. You are asked to prepare from alkane. Very often I ask you that when you hydrolyze it, acid hydrolyze, then H and OH get added in this way, gets added in this way. So your main thing is that ethene is converted to all. This is the leading idea. So you are asked to prepare this from alkene. Am I right? So naturally alkene to alcohol is obtained by acid hydrolysis of alkene. From alkene to alcohol is obtained by acid hydrolysis of alkene. You are asked to calculate, you are asked to prepare this compound from alkene. So you should first start from a alkene. So you see alkene. We will not write OH because OH introduced in the structure or reactant whenever there is double bond. Your compound is when double bond, they are after reacting acid hydrolysis, OH is being introduced in the compound. So your main is to be prepared is this. So OH has entered later on. Initial was CH3, there was no OH. So initially I have chosen this compound. And now see what's happened when I treat with acid. When I treat with acid, so the bond is withdrawn in this way. This will become minus. Am I right? So H proton will get attached to here. So what we get here is H is here, CH3 is here. One bond is there. You are getting positive sign here. Here is positive. Am I right? So to get this positive, next part is acid hydrolysis, means water is there. Am I right? So that water will react in this way. So what we get is CH3 water in this way. Am I right? And next portion, deprotonation. Very simple. Bond is withdrawn, negative sign comes here, hydrogen is added. This becomes hydrogen enters here. Bond is less, one bond is less, it is carbocation, and that carbocation water is nucleophile get added in this way, deprotonation occurs, you get this one. So this is how from alkene, your alkene is this, and from this you have got this one. You are asked to prepare this one. You are asked to prepare this one again from alkene. This one from alkene. This one from alkene. So you just write. Am I right? Again, I am telling you that you need not use OH here because your compound does not have OH. It is after acid hydrolysis you get OH. So your double bond is here. So you see first protonation, then nucleophilic attack. So bond withdrawn here. You are getting in this position negative sign, and that enters here. So bond withdrawn negative. So what we get is bond withdrawn negative, and H here vanishes. It goes here. So there is deficiency in this point. Am I right? So what we get is this is methyl group. This is methyl part. Initially in the structure there is methyl, but there was no OH in the alkene part. So I have chosen an alkene where already is methyl as per the demand of the question. So I have written methyl group here, and alkene OH should not be there. There should be alkene, and out of alkene acid hydrolysis you will get OH. So I have removed OH. I have written alkene in this way. This bond is withdrawn here. This is negative, and this H comes here. So this bond vanishes. This bond vanishes. That bond methyl group remains. So there is cation. So it is carbocation. Next part, nucleophilic attack. Am I right? So what we get is this. So you are getting this. Next step is deprotonation. Very simple. This is not tough. I am wrong here. The structure was like this. Okay, this is plus part, and here you are getting water S plus. Am I right? Deprotonation occurs. Again, I am explaining in a very short time, simple way. I have chosen this one because I need this one. I have chosen this one, and there should be alkene. I have chosen double bond here. This is methyl group. When bond is withdrawn, negative H enters here. So there is deficiency in bond. That becomes deficient center. Nucleophile attacks. OH is get attached. So O become positive. Then deprotonation occurs. You get the result. Second one. Third one is all are textual, and these are very interesting. This is not tough. You are asked to prepare this one. You are asked to prepare this one, and this again you see it is from acid hydrolysis. I need an alkene, and this is alkene. There is no methyl group is there. Am I right? So OH has entered after acid hydrolysis. So we have assumed this one. This, so bond is withdrawn. Negative sign is here. H enters here. It becomes positive. It becomes positive. Am I right? Next part again, water. Attack. You get in this way. Next part deprotonation. Our desired result is this. We get this one. Third one is we need to produce this one. So we'll choose this is fixed. Am I right? This part is again fixed. Methyl group is there, but OH is not required. So our double bond is here. So bond is withdrawn. Negative sign is here. This enters here. Positivity generate in this point. So we get bond withdraws here. H enters here. Plus is here. Am I right? Next point is this. This will attack. So you get plus deprotonated, our desired result is this. Am I right? This is all about the preparation of some alcohol from alkene. That is, again, I have taken out some of the questions. CH3, CH, CH3, CH2OH. Just you are asked to solve this problem. Immediately follow, there is a question of rearrangement. So when proton is there, that is concentrated sulfuric acid, dehydration is there, it is dehydrating reagent. So it will come forward in this position, CH3, CH, CH2, OH2 plus water get released, CH3, CH, CH3, CH2 plus, this is 1 degree. Minutely follow this step. I will show you 2 or 3 examples where each and every case there is rearrangement, and very often you are confused and you are misled. This is 1 degree, and you now choice there is any possibility of rearrangement. Yes, there is shifting. If you write hydrogen here and if you make shift of hydrogen, so what we get here is CH3, C, CH3, CH3 can be written as like this. You are getting carbocation of type 3. Am I right? Now deprotonation occurs. You will get CH3, C, double bond, CH2, CH3. So when deprotonation occurs, dehydration occurs very often from concentrated sulfuric acid. There is question of temperature. No doubt, I am not mentioning temperature. We are getting alkene. And one of the important thing I am here mentioning is that you see from that point CH3, C, H, CH3, CH2 plus 2. If I do in this way, C, another way, CH, CH2, methyl shift. There is difference and in degree. This is 1 degree. You are getting here 2 degree. Earlier case we got it 3 degree. Am I right? Now next step is deprotonation. Am I right? So if you write in this way, CH double bond CH CH3. One question I am keeping for you, whether such kind of rearrangement to get this result is true. If it is so, what will be your explanation? You try. I have shown you this. Number 2 question is CH3, C, CH3, CH3, C, OH, CH3. Again, I have used concentrated sulfuric acid, a dehydrating agent. Let's see what happens here. Minutely follow. There is OH group, there is OH group, So as per rule, we will instead the reaction this. Am I right? So there will be loss of water. You will get CCH3, CH3, CH plus CH3. Am I right? So then deprotonation. How we have enjoyed the class?